Okay, are we recording? Yes, we are. So, yeah, day 7, I guess. It has been a week. Like today is the 7th day. Uh, because I think we started on last Monday and tomorrow is also Monday. So, yeah. And yeah, so thankfully my Wi-Fi is back. It was back in the evening and it had been gone for like 2.5 days, I guess. And also the college projects that I was talking about. I am done with at least submitting a proposal for the business project that I don't know if I mentioned it, but yeah. And yeah, the application one, the like Flask and Jinja application, full stack application basically, that's still going on. Hopefully, I'll be done with it by next week or 10 days. I don't know, I'm not sure. But yeah, we'll have to do that before the deadline, which will be before 30th. And so yeah, anyways, that's it. We are on time today, I guess, and we are early. So yeah, let's just start. Let's just go ahead with where we left yesterday because as if you watched yesterday's video, you might remember that we only did one question, which was like this: give unique if there are unique elements in the array, then return true, and if not, then return false. So that was the easy question. Moving on, we were on the second question, which is to find a pivot element. Now, the statement is kind of confusing. So let's just read it again, I guess. It says there is an integer array nums, obviously. So here it is. I've also taken the same example that is given, and and it is sorted in ascending order. Okay, okay, yeah, let's just read it with distinct values. So prior to being passed to your function, nums is possibly rotated uh, at an unknown pivot index, which is k, and it is obviously less than numbers the length of the array basically. So it has been rotated at an unknown pivot index such that the resulting array is the type of let's say this array. So this will originally be like 0, 1, 2, 4, 5, 6, 7, but since it has been pivoted at index 3, so 0, 1, 2, 3. Okay, 0, 1, 2, 4, 5, 6, 7. I'm not sure if they have given the same index. Okay, yeah. Basically, when it was like pivoted, it was like 0, 1, 2, and then the third index, which was fourth. From there, it was pivoted, so it became like 4, 5, 6, 7, and then it printed the starting element. So, given the array nums after the possible rotation and an integer target, so this is rotated. This nums is basically the rotated array, and you are also given a target for the pivot. So, return the index of target if it is in nums, or return -1 if it is not in nums. And we have to write an algorithm with big of log n runtime complexity. So what can we do? So yeah, I think I said that we need to if we check from the first element, then obviously it's going to be like big of n complexity. So what we can instead do is that we can apply binary search, because we know that binary search does the same thing. Takes and it takes the mid element, and okay, so in the binary search we just need to compare mid, and then we need to compare like the key, or the target in this case, right? So, and if the mid is greater than the key, then we search in the left half, or if mid is less than, then we search in the right half. But here it's not gonna be like that, because let's say we found mid as 7, because 7 is mid in this case. And if we go by the logic of binary search, 0 is obviously less than the mid. So what we will do is we'll search in left half if we were doing binary search. But we will not be able to find it in the left half, because it's not gonna be there. Okay, so what can we do? I'm not really sure, to be honest with you. Like, I know the binary search. Mm, okay, the target is 0 right here. And then if we simply if we simply like count the mid, then what's even the point? Because it's gonna be, by the binary search logic, it's gonna be to the left of the array. But clearly it's not in the left of the array, because this is not sorted. So can we do something like sorting the array and then? Nah, that will be too much, I guess. So, hmm, maybe we can. Okay, so locating target is, at the end of the day, you know that's the thing that we have to do. So, because I was thinking that maybe we can. I don't know. I don't know. I mean, I know I should be writing some code and then checking it, but we clearly cannot produce a log an algorithm with checking the whole loop, or either like applying binary search, because it's just not there. Uh, or maybe we can like apply a what do we say? So yeah, to be honest, there is a solution, but that will be not for general case. So let's say int mid, right, which will be equal to start plus end, and whole divided by 2. So after that, we can do while start is less than end. Let's just go and check if nums of mid is greater than nums of uh, nums of okay. Is it target though? Hmm. Okay. So if we found the mid, right? So mid is basically the middle index. So if the uh, okay, so in binary search we were getting a key that was like an index of the no, it was not the index actually. Okay, I'm kind of confused. If nums of mid, let's just do target, right? Who the fuck gives a fuck? Let's just say, uh, so yeah, if nums of mid is greater than target, then we can just redefine end as mid minus one. So we'll make the end to be like, we'll update the end basically, and then okay, I think we can just do that case here. If yeah, then return mid, else we can update the start, right? So let's just see. I think this is the binary search. I think we would also have that here as well. Not sure. No, we don't have it. Anyways, so that will do the thing. It will return mid, and if it's not, then yeah, it will return whatever. And at the end, it will return minus one. So let's see if this does anything, right? Okay, where do we have that error? Line number 35. Okay, okay, this return should be here. My bad. Yeah, something is happening because I feel like this is stuck. Let's just do. Okay, let us just reverse the condition. Can we? Clearly, we broke something there. And again, we did break something. Okay, okay. So let's say mid was 7, and our target is okay. So it's not nums of target; it's just target. Okay, my bad again. It's again stuck for some fucking reason. Okay, 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 okay. Let's see. Let's just do how it was. I think uh, we have violated something else. So that's why we are, yeah, that's why we are getting stuck right here. Let's clear this. Let's just see the logic. So start is equal to 0, end is equal to nums of length minus 1, and then mid is equal to start plus end, while start is less than equal to end. If nums of mid is equal to target, return mid. If nums of mid is greater than target, uh, which is in this case, then make the end mid minus 1. So this will be the array. And then, yeah, and if it's not, then do mid plus 1. So check here, right? Is there something that we are missing in the binary search itself? I am not sure. Let us find out. Okay. So yeah, that is it. If it is not, and so if this condition never becomes true, and obviously whatever, so we'll just return minus 1, right? Why is it not returning anything? That is the question here. The things are looking okay, to be really honest with you. And this is the logic for binary search. Okay, maybe uh, let's do this mid here. I don't think that's gonna make any difference though. Anyways, so if numbers of mid is greater than target, then I do end mid minus 1, else just go ahead and do start is equal to mid plus 1 and return minus 1 if not found. Simple enough, I guess. See, now it's working for some reason. And if we, what if we reverse the logics? Then it's gonna be, I think we're gonna get the right answer if I'm not wrong. Time to find out. Okay, we are not. Uh, so it checked in the right one and it checked in the left one. So if it is greater than the target, which in this case is, make the start is equal to mid plus 1. So it will be this, right? And then it will be start plus end, so that this will be the mid. And if mid is greater than target, which is again, okay, yeah. So yeah, reversing the logic is not going to work because clearly we don't know where this thing is going to be. Okay. Uh, how much time did I spend on this? I think I need to go and see the solution. because we can't be stuck on this forever, you know. So so yeah, this thing, there's this question, right? This has two ways as it is given here. Let's just quickly see it. First is again the brute force way, which is just to uh, check the loop and yeah, compare every element with the other one. So that will be big O of n square. And there is okay, where is the fucking sheet? Let me quickly find that out. Yeah, I think I did make it, not make it, but you get it right. Mm, where is the DAC sheet? Is my question right now. Okay, I can't seem to find it. So let's just leave it for now. But yeah, the thing basically there is a DSS sheet that is there, and anyways, so this first question was the fourth question from the sheet, and so second approach that they have given is they are saying that you should have basic knowledge about Java hash sets before following approach 2. It will be taught to you in later chapters. Okay. So yeah, I don't know anything about hash sets. So okay, so here we go. They have the solution for this question. Okay, so obviously it is based on binary search. Now, let us just minimum will have index of minimum element of nums. Int minimum min search nums. And where is this min search, if I may ask? Okay, okay. So yeah, I think let's just code it along and then figure out what's going on here. So first of all, they have said that minimum will have index of minimum element of nums. So int min is equal to minimum search in nums, and they have defined a function for doing min search. Yeah, I was also like saying the same thing, right? No. Okay, no. I was just saying that we should sort the array or something, but yeah. So let's just find in sorted left or right. Yeah, that makes sense, to be honest. So there will be one part which will be sorted in the left direction and with one part in the right direction. As we can see this right here, it's left sorted and this is right sorted. And it doesn't matter, right? If it was like, so let's say if it was like this was the original array, and if it was, let's say, pivoted by 6, let's say, so that would have been 6, 7, 0. So then this would have been the left sorted, like this is this array or whatever, and this. So yeah. So, but how do we find in sorted left, right? So let's say if nums of minim uh, is less than or equal to target, and target is less than or equal to nums of nums dot length minus 1. So what does that say? It says that if index, okay, index, right? So min search, and we are passing the array num. So I think we are getting the index right here. I'm not really sure, to be honest. Why have they like defined that min search at the end? I'm not entirely sure about that. So, oh, let's drink some water. I okay. So yeah, they've messed up basically in the function names. Okay, that's very weird to write this here and then again write again return some method here which is defined later. Okay, anyways, so let me just do, okay, what should I do so that I don't get confused. Okay, fuck it, let's just smallest element index. See, now that makes sense. That what are we writing in this thing? Okay. So it is public static int min search, which is taking the numbers array as an input, right? And then so int left is equal to 0 and right is equal to, like, left is the leftmost and right is the rightmost. So basically it's binary search. So while left is less than right. Then what should you do? Then you should find mid first, obviously. Left and right minus left divided by 2. Okay, there is also some logic behind this right minus left instead of just writing left. But anyways, okay, I got an uh, important notification, I guess. Uh, okay, anyways, that was something related to Viva exams for the project. So yeah, let's not get distracted. Okay, so now we found the mid, and if the mid is greater than 0 and nums of mid minus 1 is greater than nums of mid, then return mid. So what are we trying to do here? Let's see. So left right we have to find. Well, left is less than right, find the mid. So we found the mid, and then if mid is greater than 0 and it should be nums of mid minus 1, which is this, greater than nums of mid. So if it is greater than 0 and mid minus 1, which will be this, is greater than this, then return mid. Okay. Else if numbers of left is less than or equal to nums of mid and nums of mid is greater than nums of right, then do left is equal to mid plus 1, or else just do right is equal to mid minus 1. And then at the end we are just returning left. Okay. Okay. Let's just go ahead with this comment to make it a bit Now I'm curious. Which question was it? Number 6, according to this. 1, 2, 3, 4, 5, 6. Okay. So yeah, basically this is a lead code problem only. Search in rotated sorted array, and it is asked in Microsoft, Google, Amazon, Adobe, D Shaw, Flipkart, Hike, Intuit, Make My Trip, and Paytm as well. Okay, and it's an easy level question, which we are not able to do. But anyways, we'll get there. So yeah, that's the min search. No, that is not the min search. Okay, and so yeah, if nums of left is less than or equal to nums of mid, and nums of mid is greater than nums of right, then the left should be mid plus 1. How the fuck is gonna be mid greater than nums of right? I mean that kinda makes sense, I guess. If mid is greater than 0, number of mid minus 1 is greater than nums of mid, and just return mid. Okay. Okay. Uh, and then returning left here because because yeah. Okay. So that was the min search, and then they have defined another method which is binary search to find target in left to right boundary. So it is said public static int search, and let's say int nums. We are also giving int left and right, int target. And int l is equal to left, and int r is equal to right. So while left is less than equal to, right? What we can do is that first we find out mid. L plus r minus 1 divided by 2. If mid is equal to target, then return mid. Else if the numbers of mid is greater than target, then you can just do r is equal to mid minus 1, and okay, if it is greater than, okay, yeah. And if it is not, if mid is smaller, then left should be mid plus 1, and then we can simply return minus 1 if it is not found. And then what they have implemented at the, yeah, here, so they have found the minimum, and if it is less than or equal to target, the numbers of minimum. Okay, what we were even getting, it will be the index of minimum element. So index of the minimum element here is 0, 1, 2, 3, 4, right? So if it is less than or equal to target, and target is less than equal to this, then only you should return search with nums and min and nums of length minus 1, and find in sorted right. So for that you just have to return search with nums. Instead of min, you have to start from 0 and then go till min, and target. So yeah, that makes the whole question, and now we can go ahead and do the thing, so it will print the thing for us. So okay, it was the first time, so I think I'll need to obviously revisit this a bit more times, so that we can so that I can fully grasp it. But yeah, let us maybe do the next question now. So basically it says that you are given an array prices where prices of I is the prices of a given stock on the ith day. Return the maximum profit you can achieve from this transaction. What do you mean this transaction? Which transaction? If you cannot achieve any profit, return 0. So let's say input is prices array, which is 715364, and the output is 5. So explanation is that you can buy on the second day when price is 1, and sell on the day 5th when the price is 6. So profit will be 5. And obviously buying on day 2 and selling on day 1 is not allowed, because you must buy before you are selling. So that is there. And I think that's the same question that we did in the class, which was This one, buy and sell stocks. So, is there anything given about the complexity? No, there is not. So, yeah, we just need to do. Okay, so the third question given here and the fourth question given here are same questions that we did that were done in the class. So basically, it's this buy and sell stocks, and then is this trapping rainwater. Okay, so to be really honest with you, I've not revised this, and I don't think I can write them right now on my own. So maybe we'll just see this one first. Let's say buy price, and we can just set it to the max value, and then profit, which will be set to 0, and we can just return the max profit, and we can run the loop from 0 less than. So if buy prices is less than prices which is today, uh, then okay, buy prices maximum value, which will be infinity. So okay, how does that make sense? Okay, so if it is less than, then just calculate the profit. If it is not, then just update the buy price by setting it as the price that is right now. Then go again. So again, the buy price will be compared to the prices of today. If it is less than, then calculate the profit, or just keep assigning the one. And yeah, so at one point, let's say in this example array, the first price is 7. So this will not satisfy because it is the 7 is less than infinity. So buy price will be set to 7. Then the second, at the second index, I mean at the first index, it's 1. So buy price is less than, sorry, is not less than, 7 is not less than 1. So it will assign buy price is 1. And now it will check, so buy price is 1 and the prices of I is 5. So it will calculate the profit, and it will compare the max profit with profit, and then assign the max value in max profit, and it will keep counting until it finds something. If it does not, then it's just gonna remain 0. It will be returned. So yeah, that was it. And then there's trapping rainwater. My bad. So we are giving height array, which will be, let's say, something whatever, and then first of all n will be the length. So what we can do is calculate first the left max boundary and then the right max boundary. So left max will be, first of all, you just create a left max array, and then uh, to the 0th index you just assign the height of the 0th index, and then you search, and then you run a for loop to see, to see if the height of the current, which is basically maximum, and if the current height is maximum or the pre-wet previous height is maximum. Whichever is the max, you store that, and then you keep storing it until you find another which is max. So then you store that. So that's how we will find all the left max heights for every element in the array. And then the same thing with right max is that you have to do right max and assign the height of the rightmost element, and then start running this loop from n minus 2, and run it till I is greater than equal to 0. Then trapped water will be 0 at first, and in this loop first we can count the water level. So it will be so water level can be the maximum of 2, and the trapped order can be water level minus the height of that particular index. So yeah, uh, okay, I think those are the two questions. We can attempt that later after maybe revising properly. So that was the third and fourth, and now we are left with the fifth. So what does it say now? It says, given an integer array nums, return all the triplets, which is nums of I, nums of j, and nums of k, such that I is not equal to j, I is not equal to k, and j is not equal to k. And nums of I plus nums of j plus nums of k is equal to 0. Okay. Notice that the solution set must not contain duplicate triplets. All right. And if we can find it in the sheet as well. Where is it? Okay, so I'm not really able to find this. But anyways, it should be a good question. So return triplets such that they are not equal, and they return, so they their sum should be equal to 0, and they should not be, any element should not be equal to any other element in the array. So let's just write public static um, okay, we need to output. Okay, what do we even write if we need to output an input? I'm not even sure about that, to be honest. Maybe let's just write it here. Okay. So let's say int numbers, because nums we already have. We can comment it out, obviously. Let's just comment it out. Let's say nums is equal to -1, 0, 1, 2, -1, -4. Okay. Now we need to find triplets such that, okay, there is not any like complexity whatever binding here, so I think we can do whatever loops and ifs and else and whatever we want to do here. So let's say triplets. Okay, to be honest, I've just gone blank right now. I'm not sure what to think. I'm not sure how to even write a different method that returns some arrays. Okay. Okay, see, there is this problem uses list to return the numbers and hash sets to store them. These new data structures that we will study about in later chapters. Uh, uh, uh. So, anyways, I think I will have to skip these questions because it's not just based on the arrays, it's based on like some other concepts and stuffs as well. So, yeah, the only thing that we did today again was this one question, which was finding the smallest pivot, no, whatever it was, finding the pivot element after the array was rotated. And that was a lead code problem, even though I did not do it on the lead code, but yeah. Let me see what number is it. It is 33 number question in which is search and rotated array. And even though in the sheet it is given as easy, the lead code says it's a medium level problem. So, all right, I think it's fair that I saw the solution. But yeah, I will I'll revise concepts again and then come back and revise again, I guess. Anyways, so yeah, I think that's it. I think it has been an hour today. Damn, we spent like we spent an hour on the question, on a medium level question. But anyways, that is expected because we are beginners. So yeah, that is gonna be it for today. I think I'm not gonna be stuck up on arrays. I will keep revising stuff though, but I will try to move on to sorting algorithms from tomorrow. Although I'm not really sure if I'll be able to finish the lectures and reach till practice questions or whatever. But yeah. Anyways, we'll see whatever it is tomorrow. Let's not worry about that right now. But yeah, anyways, I'll stop the recording, upload this, and then maybe do some project work too or just simply sleep. I'm not really sure, to be honest, because I'm kind of tired. I submitted the BDM project today, the business one. So, yeah, that's gonna be it. Have a great night or a day. I don't know if you have made it till here. And if not, obviously, you are not gonna see this. So, yeah, signing off. It's wrap up for day 7. It has been, we have completed the 7th day and we have completed a week. So, yeah, I guess good job for maintaining the streak and we'll keep just going. Anyways, enough for the rant. Bye bye.